So we have aluminum, followed by zinc, and then after that is iron. Let's see, is copper more active than silver, or is it the other way around? Let's see. It turns out that copper is more active than silver. And then for the corresponding metal ion solution, we have, this goes to aluminum 3+, and this is zinc 2+. This is iron 2+. This is copper 2+. And this is silver plus. Let's take a look at the standard reduction potentials. So this is table 19.1. Okay, so on this table, let's find each reaction. So let's see, aluminum going to aluminum 3+. Now it's going to show it as reduction potential. So let's look at it this way: we have aluminum 3+ plus 3 electrons going to aluminum, and let's look up the reduction potential for each one. So let's see, for this one, aluminum 3+ is minus 1.66 volts. For zinc, 2+ going to zinc, that's going to equal, let's see here, minus 0.76. And then for the iron 2+, going to iron, okay, so for iron 2+ going to iron, that's equal to, let's see, minus 0.44. For the copper 2+ going to copper, that's equal to the, let's see here, plus 0.34. And then for the silver plus going to silver, that's equal to plus 0.8. Now, how is the standard reduction potential table related to the activity series? So do you see any trend in these numbers, and does it match the trend we see in the activity series going from the, so we said that this is the most active, and this is the least active.
Would it be the more electrons that it donates, the smaller the voltage, and the less that they live, the higher?
Well, see, for these three here, they're all donating 2 electrons. Dylan.
So wouldn't it be the more active it is, the more negative voltage it will be, and the least active it is, the more positive it will be?
So what Dylan noticed is that what we're seeing here is now these numbers here quantifies the activity of the metal. Okay, because note that the standard reduction potentials, it increases as we go down the table. So note that, as you said before, aluminum is more active than zinc, zinc is more active than iron, and so on. A lot of them.
Is that the reduction potential was telling us that's the voltage that is produced, or is by the reduction? Or what is the negative and positive? What is that telling us?
Well, so we can relate this to that equation, delta G is equal to minus N times F times E. So note that if we do that, okay, so note that we have a negative number here, so we calculate delta G for this. Is delta G based on the negative E0 going to be positive or negative? This is going to be positive, so does aluminum 3 plus reduce to aluminum metal based on delta G? So conversely, will aluminum oxidize to aluminum 3 plus? We go look at the reverse. Yeah. So really, when we look at the standard reduction potential table, this table really is just an expanded version of the activity series. Not only that, we can quantify, since us scientists and engineers like to put a number on everything, we can quantify how active that metal is, or isn't. Bruce?
On the copper and the silver, if it's giving off electrons, why does it have a positive value?
Oh, in terms of this in here. So again, this is related to a standard value. So the reference value is hydrogen. So for 0 volts, that's going to be H plus 2H plus 2 electrons going to H2. That's at 0 volts. In other words, everything is referenced to this reaction here, whether it gives a positive voltage or negative voltage. So one way to look at this, note that when you're looking at electricity, there's a ground. So this is like your ground. Okay, then you measure all your voltage relative to the ground. That ground. Okay. So when you look at this, note that silver is actually, when you look at table 9 components, at the top of the table. Aluminum is near the bottom of the table. Okay, so note that silver is the least active metal of these 5. Aluminum is the most active metal, which means that aluminum 3 plus, is this going to be the worst oxidizing agent or best oxidizing agent? Okay, so again, for the metals, this is going to be the, let's see, this is going to be the best. Aluminum is the best reducing agent, or the most active. Silver is the worst reducing agent. And then aluminum 3 plus, is this going to be the best oxidizing agent or the worst?
Worst.
Yes, this will be the worst oxidizing agent. And then this is going to be the best. Oxidizing agent. So this also tells us why we find aluminum on the surface of the Earth, which there's a lot of aluminum on the surface of the Earth. Note that is it going to exist in the form of aluminum 3 plus or as aluminum metal? Yes, we said that aluminum, does it want to give up its electrons or stay as aluminum metal?
We'll say it's
You just told me this is the best reducing agent, and we said that based on what we said here, that the aluminum does want to be oxidized to aluminum 3 plus, therefore on the surface of the Earth, aluminum is going to exist as aluminum 3 plus. Okay, so that's where you see the mineral Al2O3. This is how we get the aluminum on the surface of the Earth. Those alumina or Is that corundum? Carborundum? I can't remember. I haven't taken geology in quite a few years. And then for silver, does silver exist on the surface of the earth as silver metal or as silver ion?
Silver metal.
Yeah, silver metal. Okay, because silver doesn't want to be oxidized to silver ion. And this tells that when silver ion is present, it wants to get back to silver metal. Okay. So, what two metals would you use of these 5 to make the highest voltage battery?
Aluminum and silver.
So would you use like the best oxidizing agent, the best reducing agent? The most active metal and least active metal? Trial and error? Or just go to the store?
Go to the school.
E-cell depletion method.
Okay, so note that, let's see, if you want to use the most active metal, that would be aluminum. Okay, so going back to our cell, if we exchange zinc for aluminum, and then let's see, we want to use the least active metal too, silver?
Yes.
Okay, so we change this from, let's see, aluminum and aluminum ion, and made this silver and a silver ion solution. What's going to be the voltage for our cell?
0.4 volts.
Okay, so let's see, if we take the aluminum 3 plus 3 electron going to aluminum. So let's see, for this one here, this is going to be our oxidation reaction. So this is going to be okay, so let's see, E oxidation, that's going to equal, I'm using method 2 here.
1.66 volts.
Yes, this would be 1.66 volts. And then for the reduction, we're going to reduce the the silver to silver metal. And this is going to be our E reduction. And that's going to equal
0.8 volts.
0.8 volts. And then for our E cell, that's going to be 1.66 plus 0.8, and that's going to be 2.46 volts for our battery. So note again, if you want to make the highest voltage battery, use the metal which are farthest apart on the table.
So does that mean that 1 and 2 is the same thing because the most active is reducing agent?
Yeah, so like Myra says, 1 and 2 are the same thing. So the best reducing agent, best oxidizing agent, or the most active agent, that's the same thing. Okay, so on this table, note that the most active metal is going to be your anode or cathode? Yeah, that'll be the anode. Then the least active metal is going to be the cathode. Okay. So then which two metals would you use to make a battery with the lowest voltage? Okay, so we looked at the numbers here. So we want to use Myra, the ones with, the one which are close to each other. So that would be, let's see, which one would that be? Iron and copper, so let's see, minus 0.344 and plus 0.34, those are close together.
You would think it's over.
Or zinc
Yes.
and zinc and silver?
Zinc and iron.
Zinc and iron?
Iron and copper.
Yeah, we want to go with the smallest difference.
Zinc and silver.
So it's going to be zinc and silver. You need the smallest difference is minus 0.76 and 0.8 is the biggest. Isn't the difference 1.56? Copper and silver, so let's see. That difference is 0.46, or between zinc and iron, which is 0.32. Yeah, so I think it's going to be zinc and iron. That'll be the smallest difference. So would zinc be your anode or cathode? So zinc would be your anode, iron would be your cathode, and the bulk